So right here, I'm just going to make a little bullet point. I'm just going to say y is equal to f of x, and then let's start with f of 2. We're going to plug in 2 where x is. So it's going to be 2 squared, which is 4, times 2 is 8. 2 times 7 is 14, minus 1. And now we're just going to get negative 7. That should be fine, Dawson.
They just came in the afternoon.
I'm pretty sure that's fine. If you're not sure, you can always email Dr. Norway. He will tell you, or you can show him before the exam, and I'm sure he'll say it's fine. Most people don't have more expensive calculators than the TI-84 or TI-84 Plus. I'm now going to evaluate the function at 5, because that's the endpoint of our interval. I'm not sure what the plus CE is. You'll have to email him about that. It's color, oh, then that's fine. If it's just in color, then it's fine. Doing the same thing with 5. 5 squared is 25, times 2 is 50. Negative 7 times 5 is negative 35, minus 1. So it's 50 minus 36, which is going to get us 14. So now I'm going to plug it into the equation that we have, right? F of x2 minus f of x1 over x2 minus x1. Can anyone else see my screen? Are you good now, Grant? Okay, you can see? Okay, great. So now plugging this in, it's going to be 14 minus negative 7. Don't forget to wrap your negative numbers in parentheses so you don't forget. And x2 is 5 minus x1 is 3. So that's going to be equal to 21. 14 plus 7. Negatives cancel. It's 21. 5 minus 3. It's 5 minus 2. I'm sorry. That's my bad. Yeah, this is my fault. I was thinking 5 minus 2 equals 3, and I wrote 3, so I'm sorry about that. So it's going to be 21 divided by 3. 21 divided by 3 is 7. So our final answer will be our average. I'm going to write ROC if the rate of change is equal to 7. Any questions on how I got that? On Thursday's session, I am going to be doing a function that is a trig function. So if you need practice with that, I will do that. But yeah, with the polynomial, it shouldn't be too bad. You guys should follow this, hopefully. Is there any questions over this one? Awesome. So now we're going to go to 1.2 to 1.5 on the practice exam. So we're given this graph, and that blue line, or wherever the blue is f of x. And if you need a little refresher, the dark dot, like these dots right there and right here, those mean that number is included, right, in that function. Where these open dots are, that means that there's a hole in the graph. That means that, like, f of, let's see.
Did you say included or excluded? I didn't get that.
The dark circles, the filled in circles, are included.
Included, okay.
The open circles are excluded.
Okay.
So, and a lot of these functions are a little tricky because they're they're trying to trick you a little bit. So for our first one, the limit as x goes to 2 for f of x, we see that our 2 is right here. And from the from the left side of the function, we see it's going towards 2, and the same thing from the right side of the function. Even though right here it's not included, you can still see that it's going towards, you can still see that it's going towards 1, right? This up here is trying to trick you, because the function itself is not physically going towards 2, even though f of 2 equals 2. But since the function is physically going towards f of 2 equals 1, that means the limit as x goes to 2 is going to be equal to 1. I feel like I said that a little complicated, but I hope that made sense. Does that make sense to you guys?
And honestly, anyone who's still confused about that, there's a great YouTube video from Khan Academy on that exact point.
Khan Academy is fantastic. If you are ever confused about something and me and Dr. Norton are not there to help you, I say go to Khan Academy. Yeah, it's not,
literally,
it's not,
Linux from Khan Academy explains this perfectly.
yeah, so the function itself, this blue line, is not physically going towards this point right there. That means that as x goes to 2, it's not going to be 2, it's going to be 1, because that's where the function is, that's where it's going towards. If you're given a graph like this, where it's all funky looking, yes. This is probably the only time in the course you're going to be in something like this, a graph for a limit, so this is not usually how you evaluate limits. This is just making sure that you understand the fundamentals of limits.